Hello everyone, myself Debashree. I am a research scholar working under the guidance of Dr. Biswajit Saha at CSIR-NEIST, and I have been working on the synthesis and characterization of N-heterocyclic carbene metal complexes and their application in catalysis. This work mainly deals with the synthesis of an efficient ligand system to prepare transition metal complexes. These transition metal complexes act as efficient catalysts in various important organic reactions. So my first objective deals with the synthesis of an iridium NHC complex with the help of a ferrocene-based NHC ligand.
The ferrocene-based NHC ligand was synthesized in a stepwise manner. Workup in each step was done using extraction technique, mostly with ethyl acetate water or DCM water, and the drying of the mixture was done using the rotavapor. Further, the purification of the pure compound was done using column chromatography. The final NHC ligand synthesized was washed with diethyl ether and the pure compound was dried under vacuum. The complex was prepared using Slang technique under argon atmosphere.
The complex is used as a catalyst in the water oxidation reaction. This complex gave a very good yield of oxygen, and the evolved oxygen was measured using a Clark electrode oxygen assay. Due to the presence of ferrocene in the ligand system, we call it a bimetallic catalyst. While investigating the mechanism of the reaction, it was understood that Fe2 gets converted into Fe3 followed by the oxidation of iridium 3 to iridium 4, bypassing the high valent iridium oxidation state, that is iridium 5, which is otherwise necessary for water oxidation to occur. The complex devoid of the ferrocene moiety was also synthesized and evaluated in the water oxidation reaction. But the ferrocene-based iridium NHC complex gave double the activity of the complex devoid of the ferrocene moiety. Thus, this bimetallic catalyst gave us a prescription to use for-sure transition metal instead of using precious metals like iridium. In this work, we have also utilized the oxygen generated from water in the oxidation of terminal alkynes to give carboxylic acids as product. My second objective is based on the synthesis of a ferrocene-based cobalt NHC complex for the oxidation of alkenes to obtain carbonyl compounds as product. Initially, the catalytic activity of the cobalt-3 complex was evaluated in the water oxidation reaction. The evolved oxygen was measured using a Clark electrode oxygen assay. Although the oxygen evolved by this complex is lower than that of the iridium NHC complex, yet alkenes were easily oxidized to aldehydes with very good yields at room temperature using the produced oxygen from water. The mechanism of the reaction was also evaluated and presented. My third objective deals with the synthesis of a ferrocene-based palladium NHC complex.
This complex was characterized by various spectroscopic techniques, and the molecular structure of the complex was established using single crystal XRD technique. The complex showed a 4-coordinated square planar geometry where the palladium center is strongly bounded to the carbene center. The catalytic activity of this complex was further explored in the CC cross-coupling reaction of aryl boronic acid and acetic anhydride. The oxidized version of the catalyst was also synthesized, and the catalytic activity of this complex in the CC cross-coupling reaction showed a lower yield of the product, that is acetophenone, than the reduced catalyst.
The catalytic reaction using the ferrocene-based palladium NHC complex proceeds via a palladium 0 species. This palladium 0 species undergoes oxidative addition in presence of acetic anhydride to form a palladium 2 species. The phenyl group of the phenyl boronic acid gets exchanged with the acyl group of the acetic anhydride bounded to the palladium center. This on reductive elimination gives acetophenone as the final product. The difference in yield using both the catalysts can be attributed to the electronic effect of the ferrocene moiety present in the ligand system of the palladium NHC complex. My fourth objective was the synthesis and characterization of a redox-active manganese complex. This complex was synthesized using a ferrocene-based bipyridine ligand and was characterized using various spectroscopic techniques like NMR, HRMS, UV visible, FTIR spectroscopy, etc. CV and DPV studies of this complex was also carried out. The molecular structure of the complex was established using single crystal XRD technique. The catalytic application using this complex is currently under progress. This was all about my PhD work. Thank you. Jai Hind, Jai Bharat.